this section will focus on solving linear equations using both of the properties that you've learned from section 2.1 and 2.2. So just to review, 2.1, you talked about the fact that you can add or subtract the same number from both sides of an equation and still get an equivalent equation. 2.2 said that you can multiply or divide an equation by the same number and get an equivalent equation. So we're going to see here in section 2.3 that we will have equations that will not just involve one of these properties, but both of the properties. And this is a more common type of problem that you're going to encounter in your mathematics courses. So our objectives here are to learn and use the 4 steps for solving a linear equation, solve equations with fractions or decimals, solve equations with no solution or infinitely many solutions, and write expressions for 2 related unknown quantities. Okay. So what are the 4 steps to solving a linear equation? We've really talked about these through sections 2.1 and 2.2, but here they're kind of formally stated. The first step is we have to simplify each side separately. Right, we can't go across that equal sign. We have to treat those as 2 separate expressions, simplify them as much as possible, and then we will apply the 2 properties we've learned in this chapter. Then we have to isolate the variable term on one side. In other words, eliminate it from one side of the equation. And the way we're going to always do that is use the addition property so that the variable term is on one side of the equation and the number is on the other. So after we've simplified, we've isolated the variable, then we're going to isolate the variable term on one side. They're going to isolate the variable, meaning that if there's something added or subtracted to that, we need to move it to the other side of the equation. Or if there's something multiplied by it, we're going to have to divide it to get the variable by itself. And then we can always check to see that the number we plugged in is the correct answer. Okay? So, I think it really will benefit you to see a few of these worked out as examples just to build your confidence. Practice makes perfect, right? It makes you really understanding what you're doing. So let's look at a few of these. Number 5 is 3x plus 8 is equal to 5x plus 10. This equation's not too different than what we saw earlier. The difference is that once we do the addition property, we're going to have to use a multiplication property as well. So what I'm going to do is eliminate the variable from one side of the equation. What I said to you earlier was to eliminate it. Eliminate the one that has a smaller coefficient. And the reason for doing that is then you won't have so many negatives to deal with, but you can certainly eliminate either side, it doesn't matter. So if I choose to eliminate the 3x because it's a smaller coefficient than the 5x, since it's a positive 3x, I'm going to have to eliminate it by subtracting it both sides. Okay, so if we subtract 3x from both sides. Now, you can do this vertically. Your book probably goes through that. That's fine. Just easier for me to show you and record all the steps that I'm doing in this manner. So notice that the 3x minus 3x is eliminated. We're left on the left side with simply 8. Now we simplify on the right. 5x minus 3x is 2x. And of course we have the plus 10. Okay? So now we need to get the variable term by itself. So we need to remove this plus 10. We'll remove a plus 10. Yep, you said it, subtracting 10. So notice that our 10s are eliminated. We have 2x on the right, and that's equal to 8 minus 10. For your rules about subtracting, that's the same as adding the opposite. In this case, it's negative 2. Now notice we're not done because we don't have just an x on a side by itself. So now we need to remove this 2. This is really where you have to distinguish those 2 properties. The 2 is being multiplied by the x. So to eliminate the 2, we have to divide by it. So now 2x divided by 2 is just simply x. Negative 2 divided by 2 is negative 1. So our solution set is negative 1. We can certainly check, right? What's 3 times negative 1 plus 8? That's negative 3 plus 8, which is 5. What's 5 times negative 1 plus 10? Negative 5 plus 10, which is 5. So both sides are equivalent when we plug in the negative 1, so it checks. Okay. Let's look at number 9. That just has a little bit of a tricky thing to simplify each side first. If I can squeeze it in here, it's negative 2p plus 7 is equal to 3 minus, in parentheses, 5p plus 1. Okay. Now on the left side, nothing can be done, right? Negative 2 plus 7, those are not like terms, nothing to do. But on the right, notice that this is understood to be a negative 1 that has to distribute 2. So this 3, we can find 3 minus 1 yet. Order of operations dictates that we have to multiply before adding. So the right side is really 3. Negative 1 times 5p is 5p. Negative 1 times 1 is negative 1. So when we can simplifying, we have negative 2p plus 7 is equal to, what is that, negative 5p, 3 minus plus 2. Okay. Now notice we have variables on each side. Which is smaller, negative 2 or negative 5? Yes, the negative 5 is smaller, so we can eliminate the negative 5p by adding 5p to each side. So if we add a 5p, notice that negative 5p is eliminated. On the right, just 2. Negative 2p plus 5p is 3p plus 7 is equal to 2. So now we need to get rid of the constant term. That is, we've got to get the 3p on the side by itself. So we need to remove plus 7. So what will remove a plus 7? Yep, 7. So 7's eliminating. 3p is equal to 2 minus 7, which is negative 5. Almost solved. We now have to get rid of this 3 as the coefficient of p. So since the 3 is connected by multiplication, we divide both sides. So our solution, therefore, p is equal to negative 5 over 3. Okay? And most all of these other problems are very similar to that. So your rule is you want to clear parentheses, combine any like terms just on separate sides of the equation, eliminate the variable with the smaller coefficient from one side, and then you're going to use the addition property to get the variable term by itself, and then dividing by the coefficient of x if necessary, so that you can get the p or what letter it is by itself on one side. Okay. Now, here's some frustrating problems, I think. When you have equations that have fractions in them, if you notice that we did this back in section 2.1 and 2.2, we really did not get rid of the fractions. But the nice thing about fractions with an equation is that you can eliminate them because you've got two sides to work with, so you can multiply by the least common denominator to eliminate the fractions, and that's exactly what we're going to do. If I wanted to solve number 23, which is 3/5 t minus 1/10 t is equal to t minus 5/2. Before I panic, what I want to do is try to think about how can I rewrite that so that it doesn't have any fractions. And what allows me to do this is to find the least common denominator of all the denominators, so 5 and 2. The number that those three divide into is 10. Then what we're going to do is multiply both sides of this equation by 10. And in so doing, the 10 will actually distribute to each term of the equation. So instead of writing it like this initially, you could have just taken every single term and then multiplied it by 10. I'll do that here just so you can see what it would look like. So we really have 10 times 3/5 t minus 10 times 1/10 t is equal to 10 times t minus 10 times 5/2. Now the reason for multiplying by 10 is that you don't want to have any fractions. So you want to eliminate the fractions in this step. Think of that 10 as being 10 over 1. So we say 5 goes into 10 2 times, right? The way we've selected our least common denominator is that all the denominators will divide into it evenly. So do that first. So 5 goes into 10 2 times. 2 times 3t is 6t. The 10 over 10 goes into 10 one time. 1 times 1 is 1t. Notice that we have a minus sign there, so we can simply put minus t. And that's equal to 10 times t. There was no fraction in that term with t, so it just stays 10. And then notice here, 2 goes into 10 5 times, so 5 times 5 is 5. Now, would you agree that's a much easier equation to solve? To solve that, we're going to combine like terms. So 6t minus t, remember, understood 1 there. So 6t minus 1t is 5t, equal to t minus 25. I'm going to go against one thing that I said earlier. If one side of the equation, even though the number is smaller in front of the variable, is on a side by itself, it's easier to eliminate the other term so that you can just do this in one step shorter, really, than what you would otherwise do. So what I'm going to do now, since 5t is already on a side by itself, let's get rid of the 10t from the right, and we'll have it in the form of a variable term equal to a number. So what will I have to do to eliminate 10t? Well, since it's a positive 10t, I have to subtract it. Okay, so my whole goal is then eliminated. So 5t minus 10t, be careful with your signs, that's negative 5t, negative 25. Now to get the t by itself, I'm now going to divide by negative, right, because the negative, so that t is equal to negative 25 to negative 5 is a positive 5. And that is my answer. Okay? So a long problem, but if you can stick with it, really, this step right here, you get a really nice, pretty equation, then you can go through and solve pretty easily. Now I want to take you through a problem like number 25. That's probably the hardest one in the textbook that you have as far as solving a linear equation. So let me get that one for us. It's going to take me a couple minutes to write. See if I can get it off here. So 25 is 4th times x minus 12 plus 1/2 times plus 2 is equal to x. Okay. Now, notice fractions and parentheses. What I should do first is eliminate parentheses. In doing that, I may, in turn, eliminate some of the fractions from the equation. So what I would suggest is you start by distributing. Okay. So a negative 1/4 times x is just a negative 4th x. Negative 1/4 times negative 12, realize that's plus, right? And then 4 goes into 12. Plus 1/2 times x plus 1/2 times 2, Remember, 2 goes into 2 one time, just simply 1 is equal to x plus 4. Now what you can do is combine some like terms. So 4th x plus 1/2, even though terms could be combined, let's save it so that we can eliminate the fractions first. But we can easily 3 plus 1 to get a 4, and that's equal to x plus 4. So what we want to do now is change this equation to one that does fractions. The way to do that is find the least common denominator. Least common denominator is the number that both 4 and 2 divide into, which is 4. So if we multiply both sides by 4, okay, notice, write this out as 4 times every single term. I don't mind you doing that. I would rather you do that than try to do some steps in your head and miss it. Okay, so if I'm distributing on the left, when I distribute on the right, there's fractions, so it's going to be, go ahead and say 4x 16. So notice on the left, 4 is negative 1/4 x is going to be negative x. 4 times 1/2 x is going to be 2x. 4 times 4 is 16. 4x plus 16. Okay. Terms. Now, would you agree this equation looks a lot nicer? So negative x, those going to be just x plus 16 is equal to 4x 15. Oops. Now, since we have variables and numbers on each side, I'm going to eliminate the variable with the smaller coefficient, the smaller than 4. So I'm going to, from both sides, subtract x. Okay, so this is 16, right? 4x is 3x plus 16. Now we need to eliminate the constant. So if we get 16 from the x, subtract 16 from both sides. And a pretty neat thing happens when we subtract 16 from both sides. 16 minus 16 is 0. 3x, right? 16 is eliminated on each side. So to solve, it's okay. We just have to now divide by 3, right? Because the 3 is connected to multiplication by 3. Remember that from chapter 1 is just 0. So our solution is the value 0. So we have to show that 0 was a number that satisfied that equation. Let's refer to the problems. With decimals, the method that you can do, eliminate, use your calculator. I would say just start off by using the equation. Okay. The next types of problems actually are some special cases of problems. So let me show you some special cases. Let me talk about it here. Let me see. Let me do number 45 for just a minute. 45 is 9 times v plus 1 minus 3v is equal to 2 times 3v plus 1 minus 8. Looks just the equations we've done. First thing you want to do is to distribute, right? Clear the parentheses. So we have 9v plus 9 minus 3v is equal to 6v plus 2 minus 8. Now combine like terms, right? We need to simplify each side. So if we simplify on the left, 9v minus 3v, 6v plus 9 is equal to, on the right, 6 minus 8 is minus 6. We have variables on both sides, constants on. We have to eliminate a variable from one side. This problem is unique in this case because notice that the variable coefficient is the same. So whenever I eliminate it from one side, it's actually going to be eliminated from both sides, right? If I wanted to eliminate the 6, I would have to subtract v from both sides. On doing this, 6v minus v is eliminated, so I just get 9, 6v, and I get negative 6. Notice in this problem that the variables are eliminated, so there's no way that I can solve this equation any further. So what I have to use are some of my techniques. This equation reduces down to the fact that 9 is equal to 6. Well, that is absurd, right? Never equals negative 6. This is a false statement. So if your equation reduces down to a statement, that means that there is no solution to this equation. It doesn't matter what value you plug in for v, two sides are never ever the same. Another way to state no solution is with the symbol called empty set. Just as the notation tidbit, you never write the empty set in the solution set brackets. It is considered a set itself like that. If you wanted to, just simply leave them empty. Okay, so those are acceptable ways to write no solution. Well, the other type of equation that can come up from this when the variables are eliminated and here true statement instead of false statement. So let me talk about that one. But before I do, let me mention that this type of equation is called a contradiction because it says that the sides are going to be equal. All of the other equations that we've been doing are called conditional, because there was a certain number that we could plug in to make the equation true. Now, let me show you, if I can think real quickly here, number 44. I think we'll show you what I need to talk about. Oops. Down a little bit. X plus minus 4. It is equal to distribute them. This is 4x minus 4. Okay, x plus 12. Side will 16 minus 4 plus 12. So you might already notice this one looks really different because so if I eliminate a variable from one side, I have to subtract 4x. Well, if I subtract 4 sides, notice that here again the variable is eliminated from both sides, and I'm left with this statement 12 equals 12. What happened is formed legitimate step. We got an equivalent equation to it, and that equation is just as simply 12 equals 12. If you go to a true numerical statement, then what that means is that x that you plug in is going to make this equation true. We say that is that this equation has as that all real. There is a symbol in mathematics, kind of like this bold-faced stands for real number. It means -1 would make it true, 1,000, 2/5, 0.3, 17, whatever number you plug in, get a true. And you might see that here, right? Because 4x, again, a value for x are always going to be add 12 to the number that you started with that's the same, you're going to get another number that's equivalent. So those are the special equations. This one is called an identity. Left side always equals the right. You get an identity. So you can either have conditional, which has unique solution, a solution, or an identity, which has every number as a solution. The do in this section is doing some translations. This one is having equations. If you'll notice here, we're just going to expression. This is preparing you for the word problems that are to come in chapter 2. So you have to do some reasoning here. In number 47, it says two numbers sum of 11. One of the numbers is q, and you have to find other. So we need to write an algebraic expression that q represents our other number. So one way you can think about it is this. If two numbers add up 11, right? One of them is q. How can we find the other one? Well, we can kind of use our techniques for solving equations to find this one. We would have to subtract sides, which would tell us that other number has to be 11. Okay, so that would be the other number, 11 minus q. Here's another way to think about it. Think about some numbers. We know that their sum is, I'm just going to write them as x and y, right? It doesn't really matter. Like, for instance, if the number is 2, and the other number has to be a number that adds up to 11, what have to be? What has to be 9, right? Because 2 plus 9 is 11. What if 1 is 5? What is the other number? Well, it is 6, right? Because 5 plus 6 is 11. What if the number is 8? And they add up to 11. Well, that other number has to be 3. Well, what way you're getting the other number? If you knew one, you subtract it from 11 to find out what number was, right? So if you knew 2, you had to say 11 minus 2 is 9. If you have 11 minus 5 is, if you knew 8, 11 minus 8 is 3. So this is q. The other number is 11 minus q. Okay? That's really an important concept to remember. So if one number is q, the other one is 11 minus q if they add up to be 11. Okay? Another kind of important one, number 52. Tom has R. What is the value of that in cents? Well, here's not a real life case. Let's say I have 3/4. What is the value of that? Each quarter is worth cents. So in cents, 3 times 20 is 75 cents, right? If 4/4, have 4 times 25 cents or 100 cents, which is the same thing as $1. Okay. The whole thing is, I had to multiply the value of that coin. So R quarters would be worth 25 times R cents. If I want one amount instead of 25 cents, I'd multiply by 0.25. And that concludes section 2.3. So 2.3 are equipping you And then we're going to get into the next few sections. Apply these to applications or word problems. That's it. Contact me if you have problems. Thanks and good luck.